Good morning everyone. I'm here to take the SS2 Mathematics with the topic variation. Looking at the content, variation is used to describe the relation or the relationship which exists between two quantities. Okay, when we are talking about variation, you are trying to compare two quantities on how they relate. Okay, now let's quickly look at the types of variation. There are four types of variation. We have the direct variation, inverse variation, joint variation, and the partial variation. But today we are going to look at the direct variation and inverse variation. Starting with direct variation, what do we understand by direct variation? Okay, when two quantities h and r are related to the extent that as the quantity h increases, quantity r also increases, and as quantity h decreases, quantity r also decreases. Now, in this direct variation, it's trying to explain that if a particular quantity increase, okay, that increase will tend another quantity to what also increase. But if a quantity decreases, or the other quantity also decreases. So as one increases, the other increase, and as one decrease, the other quantity also what decreases. That is what a direct variation is explaining over there. Okay, trying to compare two quantities. Now, if h varies directly as r, okay, you can see h1 over r1 equals to h2 over r2. They are trying to compare the two quantities. Okay, if h varies directly as r, mathematically your h is directly proportional to r. You can see that sign there is meant to be is proportional sign, okay, where h is equal to kr. That k that is there is the word proportionality constant. It's called the constant. Okay, then your k, when you make k the subject of formula, your k is equal to what? H over r, where k is the constant, and that sign that is over there, I was meant to use a proportionality sign, but we are just making an assumption that that is the proportionality sign, that is the proportional sign. Okay, so where k is the constant and that sign over there is the word proportionality. Now, example 1. They say given that y varies directly as x, when x is 3, y is 6, calculate y when x equals to 7.5 and x when y equals to 16.5. okay, solution. Okay, y varies directly as x. You can see that varies directly. You can see the sign over there. Okay, so if you change that proportionality sign to equal to xk, okay, then that k is the what? Constant of variation in bracket. Can you see it over there? But y equals to 6 when x is 3. That is from the question given. Okay, then if you try to input the value of x and y in that equation where y equals to xk, put y in place of 6 and x is in place of 3 from the question, then our 6 will now be equals to 3k. Then you find your k, which is the constant. Okay, then your k equals to, by the time you divide both sides by 3, then k will now be equals to 6 over 3, which is equals to 2. Okay, but from the question we are asked to calculate y when x is 7.5, and we are also asked to calculate x when y is equals to 16.5. okay, then to find y when x equals to 7.5. okay, k being 2, we have already calculated the value of the k, which is the constant, to be 2. So our y from that equation that we have already gotten, our y equals to xk. Okay, now we will now go back to those values that we are given. 7.5, we are asked to find y when x equals to 7.5. You put the value of x, which is 7.5, in that equation, and already we have gotten the value of k, which is 2. So therefore our y will now be equals to 7.5, which is x, multiplied by 2, which is k. Okay, then y equals to what? 7.5 multiplied by 2 times 2 will give us 15. That is the value of y when x equals to 7.5, and also to find x when y equals to 16.5. okay, we have also find the value of k. okay, then our y equals to sk. This is the equation that connects the two quantity x and y. okay, so since our y is, we are given that our y is 16.5. okay, then x, we are asked to find the value of x. If y is 16.5 and k equals to 2, by the time we input it in that equation, it will now be 16.5 equals to 2 times x. okay, that 2 is for the value of k, so 2 times x. So you now find the value of x, make x the sort of formula. By the time you divide both sides by 2, then your x will now be equals to 16.5 over 2. So when you divide by 2, you are going to get 8.25. So the value of x equals to what? 8.25. okay, now if you look at the observation, you can see from the question given, from the observation, as s increases from 3, that is from the question, you are given s equals to 3. As s increases from 3, okay, from the question, to 8.5 when solved. Also, y increases from 6 to 15 as direct variation. okay, when one quantity increases, the other also increases. But if it were to decrease, the other quantity will decrease. That is what direct variation is telling us about. okay, let's quickly move out to the inverse variation. Now for the inverse variation, if two quantities are so related such that the increase in one of them leads to the decrease in the other, okay, and vice versa, which means if a quantity, given a two quantity, if one quantity increases and the other quantity decreases, okay, or if one quantity decreases and the other also increases, okay, that is what the inverse variation is telling us. That is when you are comparing two quantities, then the first one is said to vary inversely as the what? Second. okay, the first one is said to vary inversely as the second. That is, when the first one increases, the other decrease, or when the first one decreases, the other increases. That is what they are explaining over there. okay, for instance, if y varies inversely as x, it is written as y varies inversely as 1 over x. If it were to be direct, you are not going to see 1 over, but because of its inversely, that is why we are getting what? 1 over after your proportionality sign. That is why y is varies inversely as 1 over x. So mathematically, your y will now be equals to what? K over x. When you replace that proportionality sign to equals to 1 over x, then you get that. okay, so that is the equation that is connecting inversely when you are given a particular question to solve. okay, example, let's quickly look at the example. Given that y varies inversely as the square of x and y equals to 8 when x is 2, find the equation connecting y and x. okay, then after looking for the equation, calculate the value of y when x equals to 6, and also calculate the value of x when y equals to what? Half. okay, solution from the equation that we have been generated before, where y is varies directly as, where y varies inversely as 1 over x. Can you see it over there? So your y will now be equals to k over x squared. You can, from the question given, you are given that y vary inversely as the square of x. okay, so that x will have a square since you are given from the question. So your y equals to k over x squared, which is the required equation. So if that is the required equation, when y equals to 8 and x equals to 2, so let's input those parameters there. Then your 8, which is y, equals to what? K over 2 square, where that 2 is the value for x. okay, so we'll look for the equation that connects your y and x. okay, so by the time we solve, a equals to k over 2 square is 4. okay, 2 times 2, which is 4, which is k over 4. Then your k, make k the subject of formula. So your k equals to what? By the time you cross multiply, so now be 8 times 4, and your k equals to 8 times 4 is what? 32. okay, that is the value for your constant. So when a equals to 6 and y equals to we are now going to calculate the value of y when s equals to what? 6. So still using that equation that connect, then that y equals to k over x squared. Okay, so which is, if your k now is 32 and your x is 6, okay, by the time you input it there, it will now be what? 32 over 6 squared. Okay, then your y equals to 32 over 6 squared is what? 6 times 6, which is 36. So 32 over 36 will now give us, by the time you simplify, that is to the simplest form, by the time you divide through to the simplest form, it will now be 8 over 9. So nothing can divide through again, so you leave it like that. So that is your value for y when s equals to 6. And also you are also to calculate the value of x when y equals to half. Okay, still using that equation, y equals to k over x squared, then your half equals to 32 over x squared. Okay, by the time you make x the subject of formula, then your s squared equals to 2 times, by the time you cross multiply, 2 times 32, then your s squared equals to what? 64 when you multiply. Then from that place where you're having s squared equals to 64, for you to get the value of x, you have to take the square root of both sides. So when you take the square root of both sides, your s will now be equals to square root of 64, which is equals to what? 8. And what is the observation here? Since this side is talking about inverse variation, you can see that as s increases from 2 from the question to 8 when solved, so as y decreases from 8 to 8 over 9, okay, as a result of inverse variation. Just go through everything what we have done today. It is well explanatory. You can see everything. Go over and over again, study it very well, and ensure that it is well understandable. Then you do your assignment. In the assignment number 1, if a varies directly as a cube root of b, and if a equals to 3 when b equals to 64, find the formula connecting the variables. Hence find b when a equals to 15 over 4. And number 2, if p, not the p, if p varies inversely as the square of q, and if q is 20 meter when p is 2.5, find q when p is 62.5. okay, in that number 2 question, that is if p, not the p. If p, please take note of that. So when you go through, try to solve and get your answer, and be happy. Remain blessed, everyone. Sir Humble, Mr. Paul.